I think we can start. Some people are still entering the room. Some seats are left here in the front as well. So good morning. Good morning. Welcome to my talk. I'm talking today, and I'm glad to do this here on DevOps Common Billion, about semi-automated penetration testing, which means using tools and using manual techniques, a little bit combining them to get an idea of the security posture of your web applications. So who am I? My name is Schneider from Cologne, Germany. I'm focusing on web security in Java, doing security reviews, doing penetration testing, giving talks and trainings and conferences. So eventually some of you have been in my training yesterday or will be on Thursday here in this venue. And today I'm speaking about the topic of penetration testing, which is what I'm doing most of my time. And I'm using lots of tools in my tool belt, and commercial tools, of course, and open source tools. And today I'm speaking about open source tools because I want to encourage you to use these tools in your daily penetration testing experience eventually as well. So just a quick poll. How many of you are working in development? Yeah, okay, that's the majority. And operations? So DevOps. Oh, well, that's actually the majority. So it could be 50-50, I don't know. How many of you are working in security? Yeah, this is just too few. Eventually this will change after the talk. And ever used any penetration testing tools? More than those working in security, that's good. So you're curious for the topic, very good. Okay, so we start with a little bit of arsenal of tools. Tools for fingerprinting, tools for web application penetration testing, tools for operation system checks, and a little bit of, which actually is not penetration testing, is tools for static code analysis. So, and the main part of this talk is about web application pen testing and penetration testing tools. So we start with the fingerprinting approach, just to get the low-hanging fruits, so to find a few things that can be easily found. And there are just a few open source tools I would like to introduce you to. One of these tools is Nikto, which is a very nice tool for scanning the web server, doing quick scans like simple leftover default configurations, default files, and eventually vulnerable installations of software that can be fingerprinted by just sending head or get requests to the domain. You can export the results in any kind of usable format. So it simply goes as to throw it against some domain, and then you see some rows, and every output row is actually some kind of finding, sometimes less severe, sometimes more. That's the low-hanging fruits that can be easily found. That's simple stuff, just like leftover Tomcat manager status installations or server status from Patchy or whatever. So what does this Apache server status mean? If you leave this kind of thing running on your Apache web server, it just gives you some throughput information, some benchmarks about the health of your Apache web server. What could go wrong with that? Noticing anything? Here you see the requests currently being processed. And if they do include sensitive data like session IDs in the URL, these can be hijacked. So even though these simple things can lead to bigger problems, so it might make sense to just use this tool and ensure that you're not having something left on your web server which you do not intend to. Also, second tool, just to get the low-hanging fruits, to test some kind of SSL or TLS cipher configuration. So you can use test SSL for that. That's a very small shell script that's reusing OpenSSL under the hood to perform lots of good SSL tests. So it's giving you, when you throw this against a domain test system or production, giving you some kind of details, what's good and what's bad. So the red things are bad configurations of your cipher suite. So using vulnerable ciphers here like RC4, whatever, that's definitely broken and shouldn't be used. And this is something you can get from this script. Or as an alternative also, the OWASP OSAFT, which is also very nice and performing these kinds of TLS or SSL checks. This was just to get this thing started here in this kind of talk. So now we're getting to the main part, and this is a little bit of very condensed information you will get. So the slides will be available after the talk, obviously. So you don't need to write everything down. So web application penetration testing. This is what we can do against test systems, obviously only. So where you have explicit permissions, otherwise you might be getting into trouble. Because these tools do some harmful checks. And the big one in the open source arena is OWASP ZAP. Anyone heard about OWASP ZAP? Yeah, that's well, 3% roughly. Okay, great. It's a very good open source tool you can use from the Open Web Application Security Project, a very good organization for web security, focusing on best practices and on tools and other things. And that's basically an intercepting proxy. So you can use this tool. It has a UI, it's written in Java, it runs on Linux, Mac, whatever Windows you need. And you can run it on your client where you drive a browser or drive any kind of web client, like a rich client performing some SOAP backend calls or whatever, doesn't matter. So usually for web application, it's the browser that you use, and you can use this Zap tool as an intercepting proxy to put this in between your browser and the backend. Just like a regular HTTP or HTTPS proxy. So it's also proxying HTTPS traffic, of course, your own traffic only. It can do passive scanning. It can do active scanning. This means in a passive analysis, just to take a look at the traffic and to see some kind of ideas or derive some kind of insecurities from that, some kind of eventually not good header that they eventually are missing to harden against certain attacks and stuff like that. That's the passive thing, just by looking at the traffic it sees while you're using your web application in your browser. And active scanning means to actually attack or to test the backend or the web application by performing certain web security attacks and seeing from the responses whether they worked out or not and whether you're vulnerable or not. Also, it's a nice spider and it's quite extensible. That's very, very open, very good. That's how it looks like. So as the majority of you here answered that you're working mainly in development, you can compare this to the IDE of a penetration tester, actually. So being integrated in the same way. And you can also save the project and persist it and later use it. And what you're seeing here is on the left side, a sitemap tree. So when you drive your browser through Zap as a proxy and you go through your application and clicking through that, you see that the sitemap tree will populate. And also you see here on the bottom area some kind of scan results, the history like a browser console and stuff like that. So it might feel a little bit like a browser console on steroids, but it's many, many more features. And you can also inspect certain requests and responses in the top right side. There's a quick start mode available, which is, well, exactly that. You can just throw a URL into that and then wait and see what happens. So, but you need to have explicit permission, obviously, and should be a test system. It's a risky thing, but it doesn't check the logged-in realm of your application. It doesn't drive into the authenticated areas. It's just scanning what it can scan on the public parts and spidering that. That's for a quick start. That's okay, but we will go beyond that. Eventually, you see some first findings from the quick start, some errors or missing headers or stuff that you can then work on. But we will go deeper. And this is now like a cookbook that you can use to use this tool to deeper scan in the authenticated areas of your application. How can we let Zap spider, for example, it has a spider engine inside the authenticated parts of your applications. There are three types of doing this. The first one is to configure the authentication inside Zap. So it's very configurable, and you can configure the type of authentication, the username, password credentials to use. It's maintaining session state and knows how to handle the cookie stuff. That's quite fine. And for the not so default authentication types, you can also script that individually. That might be a little bit complex. And the third type, which I especially like very much, is to just guide Zap manually into the authenticated parts. And this is what I'm going to speak about, semi-automated penetration testing. So you're a human driving the tool, like a programmer driving your IDE. So that has certain benefits we will see later throughout this talk. Good. So first of all, you need to use a browser and what you like to test your application with, and set up a Zap as a proxy server to use in that browser. So for this kind of thing, you open a port on Zap, just configure that kind of proxy port, and then go to the proxy configuration of your browser and simply then use this kind of port on your local machine as a proxy for HTTP and HTTPS. Then you log in with the browser into your application and just quickly also log out. So from this quick login and logout thing, you see that the sitemap tree, and this is just my training application here, the sitemap tree has some kind of first path and some first requests that it sees, which is actually your start page of your web application, the login process and the logout process. And you can use this to define the scope, which is the outer boundary, actually, for the ZAP, where it might attack certain endpoints of your web application. So by defining these outer boundaries, you avoid that it coincidentally or unwillingly attacks something else. So just use the domain or the domain and the context, whatever you would use, the path as the outer boundaries. And you can do this in ZAP by just right-clicking and state this to include in a context, and then you have defined that kind of context, where it might do its evil work later on. So then, when we want to let ZAP spider in the application and also do some kind of attacks later on, we need to avoid that the tool locks it out automatically. That would be too bad if it would just spider the logout button or any kind of logout link. That doesn't make any sense. So we need to exclude the logout button from the spider configuration. And that's quite simple. That's the reason why we logged in and logged out, that we see the logout request, and we just exclude this from the spider. Also better yet, delete it to not coincidentally use it in ZAP, so that while the session's running, you don't touch the logout. And then as ZAP, as a proxy server, is able to see and determine what kind of web session IDs are floating around from your browser to the server. Eventually you might see multiple sessions, so you need to set the current session ID you would like to use as a starting point for the spidering as an active session, just by setting this as active. And then you can spider the application. So just right-click somewhere in your sitemap tree where for all the subnodes you would like to use this as a seed for the spider. When you just do this, you will notice many requests being sent, so it's getting more and more coverage of your application, so it's performing some checks, whether it can reach other targets inside that boundary configuration. Then it will also submit forms, so you will notice that eventually you might experience state changes, so this should be done on test systems only. And it's filling out all the forms, it's clicking on all the links, trying to determine what other areas of your application you're having. And you see also the excluded one in red, which is the logout, due to our rules that we removed this from the spider configuration. So after that, just a few minutes, depending on how big your application is, it will give you a more detailed view in the sitemap tree of what your application's requests might look like. But usually, well, that's not all. So that's a typical spider problem or a typical crawler problem, where you see that many kind of areas of your web application might not be in that kind of sitemap then, because it's either that you're using JavaScript heavy configurations or JavaScript heavy applications where the spider is simply not capable of executing and finding all those links. Taking this to the extreme, this would be a single page HTML application with a REST backend, then the spider will not get all those different kinds of requests. Also, a second reason for the spider problem or crawler problem is that you need to have business valid data to submit to get to the next steps of your forms. So, for example, take a checkout process in an online shop where you have a physical address verification for the shipping address, and you need to pass beyond that step with a physical address that can be validated before you go to the next dialog step where you can enter billing information. So just a regular spider entering zap in every form field just won't get this beyond this business validation. So these are the two main reasons why we do have some kind of white spots in your sitemap that is simply not seen by the spidering. And this is where the semi-automated stuff, where you as a human driving a browser or test automation driving a browser might kick in. So in this configuration, then you can enrich those missing parts by just using your browser and just navigating to these kinds of dialogues, entering the business valid data that needs to be entered to reach into these kinds of these kinds of areas of your application. So to filling up the white spots in the sitemap more and more. And if you do have UI test automation, you can use UI test automation for this as well. So it's either you driving the browser or some kind of Selenium test driving the browser, still proxying through Zap. So after this, you now do have a very good coverage of your web application inside the Zap tool, and that's a good idea, a good moment in time to persist this kind of session. Because as the analogy goes, that's the IDE for the penetration tester. You can persist those kinds of sessions on file system, and you can later reuse them. So you don't need to do this process every time again. So you only need to adjust this when you change the dialogues a little bit, or the UI steps or the workflow of your application. So now that we've got good coverage of the application, then after manually enriching it, the sitemap tree, that's a good moment in time where we start the active attacks. And what's an active attack in those penetration testing tools like Zap? It's actually an attack where each and every parameter, each and every form field, every ingress point into your application, every entry point is permutated, form parameters, URL parameters, is permutated with some kind of attack payload signatures derived by some internal logic of these tools. So it's actually throwing all those attack signatures and all those ingress points your request of the application is offering. And it's determining by inspecting the response or taking some other side channels like timing, depending on what you're testing, whether the attack actually worked out or not. So it's performing hundreds and could be thousands of requests, depending on how big your application is. And we can do this by simply, again, just doing a cross-check whether the current session is still the correct one, just in case you have been logged out and will log in again with the browser. Just set the current session as active and then do an active scan. That actually means you choose again one of the uppermost parts of the application's areas or nodes in the sitemap tree. Do a right click and an active scan on that. And then you will experience, only on a test system where you have explicit permission, otherwise you might get into trouble, you will experience lots of requests, and the first few thousand something will be shown in great detail for you to inspect them, whether the scan started out quite well or not. And then after that, just not to blow up the memory, it will only log the concrete findings it got from that. And after a while, you will be getting some results, which you can then inspect or do some kind of report creation from that to use this later on. Giving this to development teams or creating tickets from that or just exporting that and to be fed into other tools. So you will see also in Zap then, in the Alerts tab, some kind of findings, like here from my training application. Here you will see a path traversal has been found, which is actually to permutate a concrete parameter. Here you see the photo URL parameter is filled with // URL encoded // etc/pathvd. So that tests whether the photo, which is actually a file name parameter, might be used in some kind of file access on the server side. And yes, it was the case. So here it got back a etc pathvd. Okay, it's not the etc shadow, it's just the etc pathvd. And that's the evidence collected by the tool. So that's a very, very good finding. You will also see in the sitemap tree where the most interesting, the most severe vulnerabilities are located in your application's structure due to the color of the flags. And obviously, as said, you can create some kind of reports, like HTML reports, XML reports, feed them into other tools or whatever. Okay, so the summary is first to let Zap as a tool spider in the authenticated parts of the web application, then try to find out where it did not spider actually, so due to JavaScript heavy applications, so missing business data, and then enrich this kind of missing white areas of the application to get more coverage by manually driving the browser, whatever client you use, or also by using or reusing existing UI test automation. And third, then just perform an active scan for those requests. And by the way, you can also use ZAP to proxy between a rich client and a server, which is doing some SOAP backend calls, or between a tablet or smartphone, depending on the certificate configuration, if you expose the ZAP port, the proxy port on the same Wi-Fi, to test the backend calls, the REST backend calls for mobile apps, if you like to. And as said, ZAP is very open, so the ZAP tool can be highly configured. It's highly configurable, very nice. You can extend it with lots of very nice tweaks, including some kind of configuration for input vectors before you're performing the scan. So by default, URL query and post form data are used to or actually permutate all those attacking patterns into. But when you're using a REST API, for example, as a backend for a single page HTML application, then it might be that you're having a path parameter set up into your REST API as well, which means that you're using certain or reusing certain kinds of the path as a dynamic input vector and processing that on the server side in the API. And if that's the case, you can tick the checkbox for URL path as well, so that it will also permutate all the path elements with its attack patterns. Same goes for headers and cookies, obviously. Also, you can define the supported formats, which is by default a full set of file uploads, including also multi-part MIME requests, XML tag attribute, and JSON things. That's quite nice and convenient. For example, when you're testing a rich client which is performing some kind of web service backend calls, ZAP will recognize the nature of the post body, that it's an XML request, and will not syntactically destroy the XML request. No, it will simply permutate all the attributes and the elements with its tag signatures. Same goes for JSON. So if you have a JSON structure in the request, it will then also do some kind of checks and inject some kind of tests into all the JSON attributes without breaking the JSON structure. And you can exclude or ignore certain kinds of the requests. For example, the JSession ID stuff or whatever you would like to exclude. Doesn't make any sense to test these for any kind of useful attacks because they're cryptographically strong, generated and maintained by the server. So that's not something you need to test. And also you can speed things up by removing certain technologies you're not using, so it doesn't need to check all the different attack patterns for technologies that you know that you're not using. Also, before the active scan, you can configure the threshold and the scan strength for each different kind of security vulnerability. So this depends really on what you're using the tool for. So the threshold is something which you can define as low or as high, and that's the threshold of when something should be reported by the tool. So it might be that there are some findings where ZAP is very, very firm, very certain that it has found something. Like with the path traversal, it actually got back that kind of etc password, so that's definitely a proof, and that will be reported definitely. But it could be that there are some findings where the tool is not really certain whether it found something, and it might make sense to inspect this manually, the finding after the scan, whether it really found something, but it's not quite sure. So when you're using the ZAP tool and those scans for manual inspection, then that's something where it might make sense to set the report threshold to low, which means you will get more findings, including more false positives. A false positive is a finding which actually is not a finding. So it thought it found something, but actually didn't. And when you're performing not any kind of manual processing triage after the findings, then when you, for example, using the tool in a fully automated way, which you can do also, then it might make sense to set the threshold to high, because you will not be willing to break a build or automatically create tickets from false positive findings. So then only break the builds, so less is more on these things, then break the builds when the tool is definitely certain to have found a vulnerability, so then the threshold should be set to high. And the scan strength is just limiting or enhancing the amount of time and the riskiness of the scans actually. So this is for the default, or adjusting the default configuration and performing some active scan of the whole application. So there are also, just in case you want to do some kind of certain on-the-spot scans, a way to do this. So just for example, a single request. When you know, oh, that's a very interesting request, we worked on this kind of dialogue, on this form submit on the server side, lots of processing is happening, let's scan exactly that particular single request and only on those spots where we know we changed something. So it's a quick scan, for example. So then you can just fetch in the sitemap or the history this kind of request, and then simply on the request, like here, the update runner profile post request, perform a right-click attack and an active scan. So then you have the option to manually decide on what kind of areas of the request it should put all its payloads in. So then it's quite easy for you to do the cherry picking of those kinds of areas of the request you would like to test, and it's leaving the rest untested very quick for a quick check for a certain kind of change. But you might think, and might be correct with this assumption, that the process of spidering, manual enriching, and then active scanning might be a little bit too cumbersome. It depends on what you're using the tool for. And there's another mode which I personally also like very, very much, which is the so-called attack mode. Zap's attack mode. That's something like I call it scan as you serve, actually. So that's something that the tool can be configured to do all these things while you are walking with the browser of your choice through your web application. So it's actually following you step by step, and every new request it sees, it's immediately scanned, but nothing else. So you're keeping the order of the requests, you're maintaining the business valid data you enter. You don't need to spider, so there's not the spider problem of unseen parts. So it's just that you set Zap to the attack mode, which is scan as you serve, as I call it, and then you use the browser driving through Zap as a proxy to navigate into your application step by step. And what you're then experiencing is that the request you just initiated in your browser is automatically scanned by Zap for all these kinds of vulnerabilities if it has not yet scanned before. So it doesn't scan any kind of repeated requests. So for example, when you're having an online shop, another product, another product, another product, so it only scans the product detail page one time. That's quite nice. And that can be simply defined in the Zap tool to set this to attack mode, and then you no longer have the need to have these two steps of spidering and active scanning. You're just driving the application either manually or via explorative testing or via test automation when you do have these kinds of things. Yeah, and also as being a very open tool in terms of extensibility, Zap, like an IDE, can be extended quite well. There's a marketplace available where you can download certain free plugins. Everything is open source in this area, and these plugins can enhance the types of scans or the types of attacks it will do. And I really recommend, for example, the Advanced SQL Injection Scanner plugin. More on this later on. And can be configured with custom scripts in case you really want to have the latest things to get the tweaks out of the tool or to further customize this towards your application. And as we are on a DevOps conference, of course, you can also fully automate that if you like in the build, definitely. So using the exact same setup that you proxy some UI test automation or some kind of service tests just through Zap on the test system that's triggered by some kind of build. It has a REST API, the Zap proxy tool, so it can be configured remotely while running. It has a headless mode, so it's also capable of running without UI in a fully scripted fashion. And very nice, it has an official Zap plugin for the Jenkins CI environment, so that you can simply start and just point this to the URL of your integration test system throughout the build. Very nice. Good. Okay, so this was for Zap, which I like very much. Now some other tool, which I also like very much, which is Arachne Scanner. That's also an open source tool. It's written in Ruby. It has a REST API as well, an RPC mode. It is optionally enhanceable with a web UI if you like to have some kind of UI, but usually it's a command line interface that you use just to start things. And the most beneficial aspect of Arachne compared to Zap is it has a very good spider in terms of spidering JavaScript-heavy applications, because it has a Phantom.js-based headless browser cluster. So it actually is evaluating the JavaScript of your web applications. Instead of just spidering the links and filling out the forms, it evaluates the JavaScript, giving you more insight when you run this automatically against your application's UI. There's a good login and auto-login handling, session management, all these things to maintain session state and perform scans in the authenticated areas. So as being a command line, just showing you an example of how to call this. This would be one line, obviously. And what you see here first is some simple settings of the user agent. It should just send to the server as the string or the pool size of the browser cluster, the Phantom.js browser cluster. So actually the memory amount you have for this depends on that. And also what should be scanned. So it should also obviously fill out forms and scan the links and etc., etc. Perform some auto-login handling, more on this in a few seconds. And then what to actually scan, like scan everything and exclude certain parts that might take longer than you are willing to wait. And just start the scan with the login page of your application, which will then be used to drive the auto-login settings and the auto-login handlings, which we do have here. And what does the auto-login in Arachne mean? First of all, you define a regular expression of the URL, what you like, or the URLs that you would like to exclude. Because it doesn't make any sense to scan automatically the logout, then you will be logged out again quickly. So, of course, exclude the logout or any kind of logout URL, and eventually certain parts of your applications that you know that are static, that you don't need to scan. Then you define a session check URL and a session check pattern. That session check URL is simply after the login queried to search for the regular expression session check pattern in the response, just to ensure that the login was successful. So when you're seeing the log out after you logged in, then the login was successful. Obvious test. And also you define a plugin, and the login script plugin is very nice to perform actually the login, and this can be configured using many ways, and one of that I like personally very much is a JavaScript file. When you have a JS file, just pointing to that file, then you define the login settings in Arachne, which is exactly just using the DOM access of a Phantom.js browser cluster capable of evaluating the JavaScript. So it's running on the login page exactly these kinds of JavaScript lines that you can provide to actually find username, password, fill the form and submit it or whatever you need to do. And you can easily test this before writing this by using the browser console. And then you could use that. Then when you start the scan, you will see that the login was successful. It retrieved a session ID and it will perform lots of scans, which at the end you can report. So then you can create nice reports, either XML to feed into other tools, or use the reports in an HTML format to view them in a browser. You can then inspect the findings, depending on severity, like path traversal here. So it found the same thing. From my training application, here you see the path traversal. It found the photo URL parameter // etc password, and it returned the etc password as this kind of URL parameter is actually used in a file system access. Okay. And you can also try to automate this kind of Arachne scanner in terms of fully automated scans. I wouldn't recommend it to use it on a commit basis. That will take too long. Those scans might take hours. So on a nightly basis or whatever might fit there is a better choice. You can simply schedule them either through a cron on the machine or some other driving job scheduler. So you can use the built-in UI. It has a web user interface where you can also manage the scan when you would like to have some kind of UI-based configuration of the scan profile. Then you can do some recurrence scans there as well, like scanning every night from 1 to 3 or whatever your application on the test system. Okay, so that's also a very nice tool, SQL Map. That's definitely something being very, very offensive in terms of the security checks. That's a very good one. It's definitely very, very good of checking for any kind of SQL injection in your application. So it's performing lots of checks, having lots of good heuristics of different database dialects and performing all those kinds of injection attacks, and even being able to verify it using out-of-band channels like timing and other out-of-band channels, and also to steal actually data from the test database as a proof. That's quite nice. So it can be used for verification of potential findings of the other tools, or even for post-exploitation deep checks into your system, how deeply the system is secure. So as being a command line, and a very offensive tool, only use it on test systems where you have explicit permission, you can simply configure what to steal from the database and configure a request. So it's either just a URL, or you can also enhance post parameters or headers, just like you can do a curl request, for example. And it's checking for so it's not spidering, it's only using this particular request, and it's checking for each and every parameter of whether a SQL injection is somehow something that can be abused there or not. So when you throw this against a URL, quickly here from my test application, notice that the ID parameter from the previous request is injectable against the Postgres database, and then it tries to test with certain kinds of techniques for getting data and getting feedback from the database through the web browser just by sending HTTP and HTTPS requests. And it's doing this with union techniques and checking for amounts of columns and stuff like that. Very nice. Giving you finally what it used. For example, here you can set the ID parameter to 0 union all, and then it's performing some kind of selects on some kind of meta tables or whatever. Even you can use timing. It uses timing techniques. So when the sleep function triggers, it takes 5 seconds longer than expected. And then actually there's also a proof that this executed just via a side channel. And of course, it fetches or steals the data from the database that you configured it to read. Just for example, you can read the tables, the meta tables, or the tables from the meta tables, which is the data dictionary listing you all the business tables that are inside the application's data model. So giving you an idea from the outside, just in a black box environment, of what kind of data is sitting there. And you can also fetch the column names. So what it's doing this, it's sending lots of requests to the web application and simply either grabbing the response and the data to steal out of the response. And if it managed to inject that into the SQL statement, that it will be visible in the response. And if not, it will also perform some side channel timing-based attacks to get the characters by character just by measuring time delays. Very nice. And at the end of that kind of run, you'll see a data model of the backend database that the application being vulnerable to SQL injection is having. Nicest one is to use the ---- SQL shell argument for SQL map, because then it just gives you exactly that, a prompt. And that prompt is then accepting your own SQL. So you can type any kind of SQL there. It will parse that, and it will then use this kind of select whatever you would like to do. Depending on the type of injection in the database, you can eventually also update or insert or delete stuff. It will then put this kind of SQL correctly into the request, depending on what type of SQL injection it detected, so that on the server side, when the web application is processing that kind of data and sending that to the database, it will actually trigger this kind of select to be also executed and giving you the response back. That's quite nice, like SQL Plus without any kind of login requirement, just by exploiting a SQL injection. When you think that's all in terms of what SQL Map can do, it can even go further and beyond that, being able to execute, or at least try to execute, commands on the database, actually on the Linux system or whatever system the database is running on, just by performing some creations of stored procedures or stored functions that then will execute some kind of operating system command. So it uses, if the database user is able to create or replace functions, it will use then a UDF, a user-defined function, to enhance the code of the database to actually call operating system commands. So it has lots of these different tricks and techniques for different database systems that you can then use with the OSCMD argument and just put some kind of operating system command there. And in case it works, it will execute that on the Linux user of the database. And now for the pro tip of combining different tools, So you might experience that SQL map is very good at detecting also, and not just exploiting, some SQL injections. And you can enhance, would be great to enhance ZAP as an active scanner, scanning the application security posture of your web application with those detection patterns of tools like SQL map. And that's exactly what's possible. You can then use, as I mentioned a few slides ago in the ZAP area, that you can extend it with from the marketplace with a set of plugins. And there's one very nice plugin, the Advanced SQL Injection Scanner plugin, which is enhancing all those active scan capabilities of every parameter of every request in ZAP with the same or almost the same detection capabilities that SQL map has. That's a very nice combination. Okay, now you say, well, you're using NoSQL databases, so what the hell? No, then we have no SQL injections. Or do we have no SQL injections? So there's also a tool for that, which is called NoSQL map. Obviously also trying to inject any kind of, if it's JavaScript or whatever, query language you're querying your NoSQL databases with. Good, that for SQL things. Now for SOAP services. When you're having a SOAP web service backend, there are also some kind of SOAP-specific attacks. And that's also a very nice penetration testing tool for open source one for SOAP-specific attacks, which is WS Attacker. It's performing also Java-based, some kind of SOAP action spoofing, WS addressing attacks, some certain XML signature wrapping attacks, where you just can defeat the signature verification and change data and stuff like that. It's simply like, like SOAP UI, roughly. So you just point it to a WSDL, to a WSDL file, to the URL, and then it will automatically populate the requests, and then you can choose for any kind of attacks that you can configure, and these kinds of attacks will then be checked against the web service backend. So that's for checking for the specific web service related security things. And you can also combine this approach with ZAP, because ZAP is also capable when you have a rich client that is performing some kind of backend calls with the SOAP backend. You can also then use ZAP in the attack mode, that it will automatically attack each and every newly seen request, and then just use your rich client to access the backend. And ZAP automatically detects XML and also JSON formats and preserves the syntactic structure of those XML requests, just puts into every tag, every attribute, every element, those attack patterns in, while you're using the rich client, and every newly seen request will be actively attacked with ZAP as well. So the previous tool was WS Attacker for checking for SOAP-specific security vulnerabilities, checking these. And this scenario now, just proxying or sending SOAP requests through ZAP, is for checking the back-end processing of those web services for traditional injection attacks. So it might make sense to combine these two. Good. So now we are through with the main areas, or the main area of web application penetration testing. We've got two more areas to go. One is operating system checks, which actually means to check on the Linux system some kind of configuration of issues, some kind of vulnerabilities eventually that might exist there, missing hardening features. This can be done either by, so I'll present you two tools. This can be done either by performing this when you actually have access to this kind of Linux box. So either when you're having a root access would be the best to perform the most depth analysis, the most deep analysis. And also you can do this with post-exportation scenarios where you somehow managed to execute something on the box, like with the SQL injection. Then when you manage to execute something on the box, then you can also use these tools as being non-root. The first of these two is Linus. Linus is a very nice tool. It's just a command line interface that you can run. No need to install something. You can then just execute this with a pentest audit system command. It will check for many, many things. So we'll check for system configuration, NFS, whatever storage configuration, even of printers, networking settings, obviously the open ports and stuff like that, SSH configurations, and kind of any kind of databases or LDAP servers running there. Even PHP will be checked, the configuration, proxy servers. So these are all the categories, including file permissions, including kernel hardening, hardening flags and stuff like that. That's quite nice. And when you start this, it will perform lots of checks for these categories and print you out the vulnerable things it found that you need to patch or need to update your Linux system for that. And also, you can use Linus to audit some kind of Docker files. If you like to do this, it can scan Docker files for security vulnerabilities, but I also recommend the Docker bench for security. If you're into Docker, which I also really like very much, then you can also perform scans of your Docker files, of your Docker images for security vulnerabilities. Very nice. Okay, so the second one is the Linux privilege checker. That's also just a shell script that you can use. No need to install something. Just start it on the machine. It's just a Python script. And then it will check whether you can escalate the permissions of a user to root. So when you, for example, manage to execute some code on the database Linux server via SQL injection, then you obviously, as in this Postgres example, you're executing the code you would like to execute as an attacker or pen tester under the Postgres user, not the root. And it would be nice to completely own the box, which would then need you to find a way to escalate the privileges from the user land to the root. To the root user. And this can be checked with this tool as well. You just run this on the box. It will check for lots of categories. So writable directories where they should not be writable, or sudo configuration or shadow files left over, or any processes running as root or other super user, eventually some cron job, performing some housekeeping as run as a higher privileged user, and lower privileged user can edit that kind of script or whatever. That might be nice. So there you can perform different checks, and it will also give you a list of concrete exploits that it has found that would be usable to escalate from a user to root. So then you even get the links to the concrete exploit code, to the concrete lists of exploit codes that you can use and throw against the machine in order to get root if it's not patched with the latest patches. Good. So for the last category, which is actually not penetration testing, it's white box analysis, which means when you do have access to the source code of the application, then you can also perform some inside checks, some white box checks against the source code or bytecode, or depending what language you're using. And there are more commercial tools available in this area, but also we do have a few open source tools. And when you're using Java, there's one very nice one, which is find security bugs, or just find sec bugs. It's well, it's not find bugs, or actually it is find bugs, but it's a plugin for find bugs. So most of you know find bugs eventually, just that small tool stating that, well, that catch bug there is eventually not good, and your logging is not good, and that might be imperformant code. Well, yeah, you're right, but with other problems. And but this little small developer annoying tool has not really too many good security checks on its own, but it's very well connected. So Find Security Bugs has a perspective for every major Java IDE, Eclipse, IntelliJ, NetBeans, Android Studio, wherever you write Java code with, you can get find bugs or find bugs as a plugin or perspective into that. Also, there are find bugs plugins for Jenkins and other major CI servers, also for including in Sonar scans and stuff like that. So it's very well connected. Maven plugin is existing for find bugs, but only the security checks are not that good. But that's not a problem, because find bugs can be extended via rule plugins. So that actually means you can have a plugin for a plugin. And there's a plugin that has been created, a very good one in the open source area, which is Find Security Bugs, which is actually a set of over 110 and counting very good security checks for checking anti-patterns of vulnerabilities inside your Java code, which is actually the bytecode. So it's a bytecode analysis framework. Find bugs. It runs within find bugs, so it can execute in all these very nice IDEs, or in the Maven build, or in the CI system. So everywhere where you can run find bugs, you can enhance that with the Find Security Bugs plugin, and then you get the very good security checks from the open source era. Very nice, including in the IDE that you can use also. yes, the tip is to disable all during the security run, all the other checks, because you don't want to get 3,500 logging statements are not that good, alerts and 2 vulnerabilities in terms of an injection. So just only check for the security things and not the other things when you run findbugs with security enhanced, so that you see the right spot. And that's actually just a screenshot of the findbugs perspective in the Eclipse IDE. So what you're seeing here is on the left side the list of the findings grouped by severity. And on the top right side, you actually have a code pointer to the vulnerability. So where it found something, the sink, where it triggers, or might trigger, depending on how sure or certain the finding is. An explanation error giving you some kind of insight of what went wrong there in terms of security and how to fix that. And you can even collaborate on that. So there's a way to set up a on-premise, of course, might make sense, a collaboration server from findbugs where you can then collaborate eventually from the developer and the security analyst, which is doing some pre-screening of the results or some triage or something like that, or discussing about how to fix that. That's pretty nice. What about other languages than Java? Yeah, so we also have for JavaScript and Ruby on Rails, for example, very nice open source security checking tools for static source code analysis. So for JavaScript, you can use the scan.js rules, the former Jenkins rules in ESLint, just using the rule set. That's very nice to check for some client-side JavaScript vulnerabilities, so like DOM-based cross-site scripting or stuff like that. And for Ruby on Rails, for raw applications, you can use Brakeman, very nice name, Brakeman, to perform some kind of security checks for your Ruby on Rails applications, whether you have some kind of vulnerabilities in your code. Very nice. Okay, and finally, there's also a very nice check. It's actually not source code or bytecode or whatever. No, it's just configuration, but in terms of a security vulnerability, that also might be an issue. So there are some risks that are coming from the dependencies that you're using. So when you're building something in Java, just make up your mind what your typical webinf lib is including. So there are lots of jar files in that. And so all those dependencies that you manage in your Maven POM can be eventually vulnerable. There can be a vulnerability in your web framework version you're using, or in your whatever frameworks to send emails or whatever, or process images. These libraries might contain vulnerabilities. And if not these, eventually the framework's transitive dependencies, which are the dependencies of the dependencies. If these contain vulnerabilities, you might expose them without knowing as well. So that's a risk you usually have, and that's where you need to have a process in place for patch management. We know this process from the operations. They are patching the Linux system or Windows system. They are patching eventually the application server. But what a typical operations team is not patching is the framework libraries that you're using. So they're not unpacking your WAR archive and exchanging 2 jar files and repackaging and hoping it runs. No, this is what needs to come upstream from the dev part. So of the DevOps, that's basically what needs to be configured up front in your dependency configuration. But you need to have a way to find out that you need to patch. So either you can do the research daily, whether some new vulnerabilities have come out, or you can use a tool. And there are free and open source tools and also commercial ones. And from the OWASP, the Open Web Application Security Project, Dependency Check, that's a good open source tool. So what it's actually doing, it's performing, when run under the build, as a Maven plugin, for example, is performing all those checks whether the Maven dependencies that you're having in your build, including the transitive ones, are vulnerable to some existing known vulnerability by comparing them to the CVE lists. CVE lists, common vulnerability and exposure, that's the CVE ID assigned by the MITRE in the US, or it's an organization assigning those numbers to vulnerabilities that are publicly known and widespread used things, mostly software, libraries, frameworks, components, whatever. And it's performing a check by downloading all those CVE lists on the first build and checking the dependencies of your application against these CVEs and flagging those that have risks or vulnerabilities attached to that. And on a daily basis, when you build the system again, it's only downloading a small delta from that. So it's a very nice Maven plugin, also a very nice command line script that you can use to check all those dependencies. There's a Jenkins plugin also available, which is nice for reporting and configuring thresholds of when to break a build. So for example, when you have a vulnerability being found in one of your dependencies higher than the CVSS score of 7, you can, which is shown quite high already, then you can configure the build to automatically break, or at least become unstable. It's giving you nice reports when it found something, including the CVE number itself and the score and some kind of further links where you can go into more details. Like here you see some vulnerability in a Spring library, so that's also very nice. And the pro tip for JavaScript dependencies, that's also something very nice to check. You can use JavaScript dependency checks for checking the client-side dependencies, or when you're using Node.js on the server, the server-side dependencies for vulnerability or for existing vulnerabilities in those versions. So when you're using a jQuery or whatever, or Angular version that's vulnerable and known to be vulnerable, outdated, not patched, you can use retire.js, which is quite nice and very nice tool as a command line script, or there's even a Maven plugin existing to check whether throughout your build those client-side or server-side dependencies with JavaScript are containing any known vulnerabilities. Good. So that's all for the tools. We are through with the talk. So this was just, and the slides will be available at the conference website after the talk, as usual. This was just to give you an impression of what the open source tool set is offering you to perform security checks in your applications from the outside, from the inside. I really would like to encourage you to use some of these, if not all, and perform some more checks throughout the build, manually or after some kind of certain releases are planned. And also to use them on a automated fashion if you can, and also do the inside checks with the white box analysis, the tools on the previous sections. So that's something I really can recommend. Good. So we still have 3 minutes left for Q&A. So in case you have any questions, feel free to ask. Otherwise, I say thank you. Any questions? Or later? Also, no problem. Yeah.
So when would you turn to a commercial tool?
Yeah, the question was, when would you turn to a commercial tool? That's a good one. So I use commercial tools as well, and they are also quite good. So, but I don't want to recommend a certain vendor. So I use open source tools for these talks, and I'll use them in my work as well. The point is, depending on whether you're a big organization, then getting a commercial tool might be something that should be decided from the central security team, and to define a process for that, to find ownership for that. Otherwise, it wouldn't work out. And then evaluate different kind of commercial tools depending on the technology stack you're using. And when you're a small application, a small corporation, that might be a little bit different. Then you can use the open source tools to start with. So usually I recommend the commercial security tools to use from a top-down approach. So to use a good evaluation of a good vendor, a good tool set, matching your technology stack as a top-down evaluation process, and then giving this in a pre-configured way to your teams. And I would recommend the open source tools as a bottom-up approach. So when the team itself wants to decide to use a security tool, these are the tools you can use today, open source and available. And when you use the bottom-up approach and use the open source tools, then you gain experience in using them. You define the process in using them. You learn from these tools. You fix vulnerabilities, what they can find, and then you've got a good foundation for then deciding on what to go next. And these might be the commercial tools then.
And are commercial tools sometimes functionally superior to the open source tools?
Yes, in terms of the question was whether the commercial tools are somehow superior to the open source tools. Yes and no. Mostly they are superior in terms of either management centralized or either the scan strength. So they are scanning more deeply and more intense and having better engines for that than the open source ones. But also on the other side of the medal, the open source tools might be, depending on what you're using, more configurable, more open, more scriptable, more integratable. So that the mileage really varies. And I use both. So I really recommend also to use both. depending on the license model, you can use for the more security sensitive parts of your teams, your applications, the commercial ones, and for the not so security sensitive stuff, eventually, depending on the license model, then the open source ones. Other questions? Good. Okay. Thank you.